So in our last video, we talked about the difference between Web 1, Web 2, Web 3, using the media, social media, as an example. And I said there is the technology behind the Web 3. Today, we'll be trying to understand the technology behind this Web 3, which is the blockchain. And also, we'll discuss about the components of the blockchain. So let's get into it. So for today, we'll be looking at what is the blockchain and comparing Web2 database with Web3 blockchain. Then we'll look at how the blockchain works and its components, then application of the blockchain. So let's get into what is the blockchain and compare Web2 database with Web3 blockchain. So from the image you can see, you can have a sense or a pictorial representation of what the blockchain looks like. It's just blocks containing information, data, and transaction linked together with a chain that forms the internet. So blockchain is just a system where data is stored in a digital block and are linked together in a chain, creating a secure and tamper-resistant record of transaction. Each new block connects to the previous one, forming an unbreakable chain that ensures transparency and trust without a central authority. The best thing about blockchain is that you cannot edit an information out of it. Instead, what you rather do is you add a new block to confirm the original one. For instance, if you had a block that has the wrong data, you can't edit it out. All you have to do next is add a new block that has the correct information. This way, when people go through the internet to search through this data, they can see the one which is not correct and see the corrected one. That's what makes it tamper-proof. For instance, if you decide to remove this block now, it would scatter the internet, which is obviously impossible. So that is all about the blockchain. So let's go further. So right now, let's contrast the tech of Web 2 with Web 3. As we all know, Web 2 is centralized. What I mean is there is a central authority that controls all the activities that goes on in Web 2. For instance, in your financial system in Web 2, you have the bank. For the media in Web 2, you have the platform which you use. You have the Facebook, Instagram, and all that. Financial system, you have the bank, name them. So because they are in control, the system is centralized. For instance, if you need to send a transaction from your end to your friend end, there is a central authority that needs to validate this. Okay, they are in control. But the thing with Web3 is taking back control and giving it back to you. Okay, in the sense that someone don't have monopoly over how the system works, like in Web 2, where there is monopoly. Yeah, let's call it monopoly. So let's come out how the Web 3 work. As I said, Web 3 is a peer-to-peer decentralized web network, and all these computers here are nodes. Okay, we call them nodes. They are linked together. We call them nodes. Unlike in Web 2, where it's just one person who can favor anyone they like. In Web 2, you can't do that. All these computers here are nodes and they validate the transaction together. In fact, there are thousands of them everywhere across the world. So let's see how they work. For this case, we've seen that here there is a central authority, but here there is no central authority, meaning information transaction are validated by nodes. Okay, and each and every one of these nodes must validate the transaction for the transaction to go through. If this one now decided to be partial, okay, and don't follow what is agreed, and this other one is okay, if this one decides to be partial, this one I'm talking about decides to be partial and send a wrong transaction and try to validate a wrong transaction instead, each and every one of these nodes will see it. Okay, I know that it's wrong, so the transaction will go through. It's not something one person has control over. It must be the same across all before it can be validated. That's what makes the blockchain tamper-proof, as I said earlier in the first slide. But let's go forward. Let's go forward Okay, before we go into example using a transaction as an example of how the blockchain works, let's look at the key components of the blockchain you should take note of. Number one, we have the block. Each block contains a set of transactions, okay, a data, information you add on this block. And when this block is created, it's added, it's linked to the chain. Okay, and once it's linked, you can't edit it out. It's tamper proof. Then we have the node. The node are individual partners that maintain and verify the blockchain data. Okay, these individual basically verify transactions on the blockchain. We can have full nodes, we can have minus node, we can have lightweight nodes. This bootcamp is not for technical people, so let's just end it there. All those types of nodes should be for technical people. But yeah, just nodes validate the transaction. Okay, and you can't have just one node. The more nodes you have on your blockchain, the more decentralized it is. And you can't have just one node on your blockchain. The more nodes you have on your blockchain, the more decentralized it is. There is a lot of nodes across the world, and the more you have more of them, the more decentralized your blockchain is. Now let's go into the third one, which is consensus mechanism. I want you to pay good attention to this component called a consensus mechanism, because it's the method by which network participants, these network participants now are these nodes. It's a way they agree on validating transaction on the blockchain. Now, when we talked about Web 2, we said there is a central authority that decides how everything happens on the internet there. For instance, in the financial system, we have the bank. They decide which transaction go through and decide which transaction doesn't go through. Okay, but in Web 3, where there's no central authority, how is it done? Especially when you have a lot of nodes, thousands of nodes across the world. There needs to be a way where everyone agree to validate transactions on the internet, and that's what's called consensus mechanism. Okay, it's basically a method where they agree this is how this transaction should be added in the blockchain. For instance, in Bitcoin, Bitcoin uses something we call proof of work, meaning when a transaction is initiated, it comes with a type of hard mathematics you have to solve. It's kind of like just see it as mathematics. Now, the first miner to mine to solve the math. Okay, it's called proof of work. The first miner to mine the first miner to solve the math and add the block to the blockchain will be the one to earn the fees from it. Okay, and since it was the first person that mined it, it's called proof of work, and that's how it gets the fee. In Ethereum, it's called proof of stake. Okay, proof of stake is quite different from proof of work. So these are things you research on. So this is on Bitcoin. Proof of work is the consensus mechanism of how these blocks are added to the blockchain by these nodes. On Ethereum, there is proof of stake, which is the consensus mechanism of how blocks are added to the blockchain by these nodes. So take note of each of these factors, because they are the three most important things you want to note in a blockchain. So let's move forward. Okay, yeah. So this is an example of how transaction works on the blockchain. Let me explain this. Now imagine you are user A and you decide to request a transaction. Now if you want to send $5, once you initiate the transaction, the request is broadcasted to all the nodes on the blockchain. We have thousands of these nodes across the world. You have in Africa, you have in Nigeria, you have in US, you have in Mexico, you have in Philippines. They are distributed everywhere across the world, and that's what makes Web3 and the blockchain decentralized. So they all have to agree on this request before it can be validated. Okay. Now imagine you don't have $5 in your account and you try to request that transaction and try to send it over. It would be rejected. But if truly you have this $5, once you initiate the transaction, all these nodes will validate it automatically. And once they validate it automatically, if it's a blockchain that is proof of work, let's imagine this example I'm using now, it's a blockchain, it's a Bitcoin blockchain. Once it's validated, the first person to actually solve the math that validates this transaction, okay, will be the one to add this block into the blockchain. And since it's the one that added this block into the blockchain, it will be the one to earn the reward for it. Okay, I didn't have a space for reward here, but yeah, the first miner to add this block to this chain will be the one to get the reward for it, and that's what's called consensus mechanism. The way these blocks are added to the chain. So once these blocks are added to the chain, the transaction is complete. That's basically how the blockchain works. So you request a transaction, it's broadcasted to the network. Each and all these nodes across the world have to validate it. Then the block is created. Okay, let me say something about the block. Thousands of transaction and data are added to the blockchain. So you don't expect just one in the block. You have a lot of transaction and stuff inside of the block. But the first bundled inside the block, the first node to actually like solve the arithmetic problem. Now I'm saying arithmetic problem because this is a Bitcoin blockchain. We really want to add this block to the blockchain and get the reward, and from there the transaction is completed. All this happen within minutes. Yeah, minutes, and that's how the blockchain work. All right, so let's look at the application of the blockchain. Okay, from here you can see it can be used in finance, decentralized finance, obviously lending, borrowing, and paying payments without intermediaries. It can be used in healthcare too to secure patient records and ensure data. We've seen a lot of patients' record being mismatched or lost, but imagine it's stored on the blockchain. There won't be much error. It can be used in the voting system too. We've always seen that you can't be very sure where your vote is going to. So these are 10 the blockchain solve. Everyone wants to know where their vote is going through, and blockchain can solve it. It can be used in real estate. One thing that everyone have come across are a lot of people fighting for same land or fighting for same house, saying that but if the record was actually published on the blockchain, everyone can truly verify who actually owned the house. So it can be used in supply chain, e-commerce. It can be used in securing intellectual property and all that. Blockchain has a lot of use cases, but just research on that and you see, just research on the internet and you see it. You see a lot of them. So for the tasks and activities, research on how the Ethereum blockchain works. Write about its blocks, the nodes, and its consensus mechanism. Write how these three things works on the Ethereum blockchain. All right. See you in the next video.